molding sand, green sand, and other sand, facing sand, dry sand, loam sand, parting sand, all these we have mentioned. Then the desirable properties, what are the desirable properties of molding sand, and how the properties are tested in laboratory, that was also mentioned. Now today, that time I had mentioned that green sand, sand molding is one of the technique. That is, sand is one of the molding materials. There are some other techniques for very fine objects or fine jobs where surface finish requirement is very high, or some other properties are required, or very intricate. Intricate means very thin section, very thin, like foil type sections are to be produced. So in those cases, sand casting is not the answer, because sand casting, sand as a molding material will give you very rough surface, and the uh, intricacy, that is geometrical accuracy, can't be maintained using sand as a molding material. In those cases, some other materials are also used. And accordingly, we have some other techniques like, say, precision or investment casting. So what is precision or investment casting? That we shall discuss today. So here I am sharing the slide. Okay. Now is it visible? Okay. Now precision is a special process to produce very smooth, right, highly accurate casting. That is, dimensional tolerances are to be very fine. And in case of, say, sand casting, we may we may use any material like ferrous metal, non-ferrous, all these. Similarly, here also, for precision or investment casting also, both ferrous and non-ferrous. Non-ferrous means aluminum alloys or magnesium or bronze or anything. Okay, so all the metals can be used. So this is a particularly suitable, is very important to note, not only accurate and smooth, but particularly this is the importance of this casting. This is particularly helpful for radioactive materials. Radioactive, you know, it is not possible to handle radioactive materials uh, quite ordinarily. Radioactive, very dangerous. But sometimes it is needed to produce something with radioactive materials. So that time, these precision casting techniques are the answer. Not ordinary. Any ordinary casting can't solve the purpose. Also, there are some very hard materials, difficult to be machined, unmachinable, almost unmachinable materials. That is very hard, which can't be machined very easily. For those type of materials, this precision or investment casting is the process. So both complex part geometry, accuracy in dimensional tolerance, all these are very important, particularly unmachinable alloys and radioactive metals. These are the very important application area. However, this is not the process suitable for mass production. Mass production
স্যার কি শোনা যাচ্ছে না স্যার?
I think the sound speaker is 100% with me. Uh, হ্যাঁ হ্যাঁ হ্যাঁ
এবার ঠিক আছে, এবার ঠিক আছে।
শোনা যাচ্ছে এখন?
হ্যাঁ, শোনা যাচ্ছে।
আচ্ছা, ঠিক আছে। So we may use sand as a molding material, but except sand, various other ingredients, as in the last time we had mentioned that sand is not the only molding material. So here, like say ceramic, we may use ceramic, plaster of Paris. You are many of you are familiar with plaster of Paris. Perhaps in your school days, there was a subject that is arts and crafts. Okay, so where you produced something using plaster of Paris. Maybe many of you are familiar with. Similarly, we have this wax as a molding material. Wax. So in this way, there are various other ingredients to be used as a molding material. Molding material means preparation of the cavity using that material. So precision casting technique may use sand. Sand may be used also, but in the majority of the cases, ceramic, plaster of Paris, plastic, wax, all these are used as a molding material. And the mold is prepared with those materials, then molten metal is poured. Okay, then after solidification, the cavity or mold is broken. Okay, and the purpose is to produce very fine casting, and the weight of the produced part may be very less. Like say, common range is 125 to 250 gram. You just imagine 125 gram to 250 gram. Even 1 gram parts may also be produced. Like say, you think about some jewelry ornament, some gold items. So that is very costly. So if you now say think about any ornament, earring or any fine jewelry item. So if you want to produce the mold using this sand and pour molten metal means gold here in that cavity, what is the wastage? And that fine shape, that is intricate parts or thin sections, can't be produced, right? But in this precision or investment casting, the techniques is so that we can produce very small, that is light job, 1 gram, very thin foil, like say 1 millimeter to 2.5 millimeter thickness, 1 millimeter thin foil molding. So that is also possible. So what are the advantages? Very intricate forms, that is very complex shapes also. Intricate means where there are various sharp corners, edges, undercuts, all these. Intricacy and complex geometrical shapes. Okay. So those very complex shapes, intricacy, intricate part can also be casted. Surface finish obtained is very smooth. Dimensional accuracy is very good. That is, surface smoothness and dimensional accuracy, you know about the tolerance, that is the deviation in both upper and lower sizes. You have the idea, say I am preparing a shaft, a cylindrical rod, right? Shaft. So exactly the same diameter, say 1 millimeter is required. That is not possible to be produced. So I must tolerate some upper deviation and lower deviation. So here tolerance may be close to plus minus 0.1 millimeter. And surface finish is given in terms of RA, roughness, micron, RA. So surface roughness may be 1 to 5 micron, is very small, very little, less. And last one, D, is the most important advantage, that is both radioactive metals and unmachinable alloys can also be casted, right? So these are the advantages, but there are some limitations also, like this process is very expensive and generally limited to small casting. Though I can produce cast part up to 10 kg, but for larger casting, unless otherwise it is a very special type of materials, unmachinable alloys or radioactive metals, I don't go for precision investment casting for larger jobs. Okay, generally it is applied for small casting, and difficulties may arise where cores are involved. Now, what is core? Again, that will be discussed in detail, but for the time being, we know that core is provided where the flow of molten metal is not desired. Okay, and how the cores are inserted using core print on the pattern. When I am preparing the mold cavity using a pattern, so on the pattern there are core prints that I had mentioned. Those are core prints, protruded parts, and core prints will provide the seat of the core, seat where the cores can be seated or can be fitted. Cores are prepared separately using core sand or other materials, maybe wooden core or something, but preferably it should be prepared with core sand and then inserted in the core seat or seat of the core. Okay, so this process is difficult to be applied, particularly where cores are involved. And in all the stages, very precise control is required. That is, the manpower skill requirement is very high. So all these involve cost. So this is a costly process. Now again, precision or investment casting, this is a technique where I have defined what is precision and investment casting with its advantage and limitations. Again, there are various types of precision or investment casting, not a single. Now, first one, as we are observing, this is shell molding or only molding. Shell molding or shell casting. Now, spelling of this molding, here you just observe MOULDING, MOLDI, both are correct. One is American spelling, one is British, so both are correct. In different books, you will observe different spelling, MOLDING or MOULDING. Now, this is shell molding. Just in a nutshell, I am, because you will find all the details in any book, theorem in classical books of workshop technology, as I had mentioned. But to discuss with what is actually going on. Now here, say the material here is silica sand. In the shell molding, the material is silica sand, not other ceramic or plaster. In shell molding, the material is silica sand, dried silica sand. And what is the size of that sand is 100 to 150 mesh shapes. Now you know what is GFN, grain fineness number. So this is as per British standard. The concept is same. Now you know what is a GFN. We had mentioned how the experiment is conducted in laboratory. What is the meaning? So when it is 150, what is the meaning? It means that if a standard diameter of mesh, that is, what is the standard diameter? 208 millimeter, right? That sheave is divided in 150 equal compartments, then all the samples would exactly pass through the mesh. So that is the meaning. So 100 to 150 BS mesh sheave, sand is selected, silica sand, dry silica sand, and it is mixed with phenolic resin. Now phenolic resin is one synthetic binder. Phenolic, we know clay is the naturally available binder, and that is to some extent inferior in quality. We may also use molasses, but again that is inferior in quality. So here for good casting, because we know precision investment casting must have some desired properties, as just now we had mentioned. So to maintain all this property, we should use some good quality sand, some good quality binders. Additives may also be used. So dry silica sand of 100 to 150 mesh sheave size is mixed with phenolic resin as binder. Okay. Now phenolic resin may be polyesters, urea, phenol formaldehyde, etc. Phenolic resin, either polyesters or urea or phenol formaldehyde. Okay. And all these are mixed thoroughly in a Muller. Muller means is a mix. Say this is a Muller or a dump box here. These both the ends are pivoted here, and this dump box can swivel right in this way, in up and down manner, right? So what is done here? Here is an oven here in the top right hand corner. There is an oven. So now hit the job, that is the pattern. You prepare a pattern using, say, very fine element like, say, copper or aluminium or any other material, master pattern, that is the replica. Okay. So preheat that pattern. So what is the desired temperature? After some time we shall mention. But overall process is, this is the pattern. This is now placed in an oven. Okay. And set the temperature for some time. What is the time? What is the temperature? Again, after some time we shall mention. But previously heat the pattern, metallic pattern, not wooden pattern. Mind that, not wooden pattern. Here metallic pattern is needed because it is easy, or on the metallic surface you can provide the shape and geometry very easily, so that it will not, after some time the pattern will be damaged. And this wooden pattern can't be heated also in an oven. So use a metallic pattern, preheat the pattern, then you fill this dump box with this mixture of molding material that is mixed with resin and other ingredients. Okay, place this molding material inside the dump box, and uh, this is the open mouth of the dump box. Now cover this open mouth with this heated pattern, right? Cover this open mouth with this heated pattern.
Yes, sir.
And then after swiveling, you just turn this dump box in upside down manner in this way. Tilt the dump box in upside down manner so that all the mass here, molding material, falls on this plate. Is not it? If you tight the top, if you just place the pattern on the top and then invert this dump box in upside down manner, so all the mass will come down, will be deposited on the this plate,
Yes,
right?
yes,
And then settle for 2-3 minutes so that all the materials are deposited on the plate. And then again uh, remove this plate, where now the plate is adhered with the molding material on the top, right? So previously it was only the metallic plate. Now after this process, this plate is adhered with the molding material thoroughly. So now again place this again inside the oven for settlement for some time. After drying, you just remove the pattern from the material. So now this is a shell, half portion of the shell prepared with this molding sand. So I am preparing this one part of the shell using the molding material. Similarly, another part of the shell will be prepared, and then the two halves will be joined here. Like, concept is just like cope and drag half. So one part and other part. So two parts will be joined by guide pins. And now pour molten metal. Say this is the elaborate, you may say enlarged view of this. This is the now your mold prepared with molding sand. How this is prepared? Using master pattern, metallic pattern. Preheated metallic pattern is placed on the dumb box. The material is deposited on the pattern. Then again it is heated in an oven. After solidification, the metallic pattern is removed or ejected and the ceramic mold is prepared. And then the two halves, that is scope and drag, concept is scope and drag, though they are not placed in upside down manner or up and down way, but it is placed horizontally. But anyways, there are two halves and then align properly and molten metal is poured. And after solidification, break this mold, get the metallic pattern. So this is the process all about. So now these are the diagrams in the next figure, that is in the next. So we had mentioned that this phenolic resin and sand is mixed to prepare the molding material, and then after preparation of the molding material, these are the steps. And I had mentioned the temperature time is to be adjusted. In the next discussion we shall observe what are the temperature times and all these. Now, as I had mentioned that sometimes some additives, now are you getting this slide? In some special character, if some special characteristics, that is, say better surface finish or high thermal resistance, high thermal resistance or strength to protect distortion and some other compressive strength or other strength is required, then those are to be enhanced by adding some additives. We have mentioned about additives. What are the function? To enhance some properties or qualities of the molding material. Similarly here, we may use some additives. Like what are the common additives? Maybe coal dust. We had mentioned about coal dust, sea coal, that is finely pulverized powdery coal, which will increase surface finish or it will give the thermal resistance. All these. MnO2, manganese oxide, may also be used. Ammonium borofluoride may also be used. Lignin, iron oxide, all these are some additives. Those are used in shell casting, shell molding. So what are the additives? Coal dust, manganese oxide, ammonium borofluoride, lignin, iron oxide, all these. And not only this, here a special lubricating material. Previously in our hand molding operation, sand molding, green sand molding, we had not used any lubricating material. But here, as this is to some extent a machine molding, so and very precise molding also. That's why, pardon, সবসময় না এখন কখনো
ঠিক আছে।
sometime in ordinary molding, in green sand molding, we don't use lubricating material. Okay, we don't use. But in this special casting or in this precision or investment casting, we use lubricating material. Okay, why? Because this is a machine molding basically, right? Not manual but machine molding. And not only that, very intricate part is to be produced, so lubrication is needed here. That's why along with additives and binders, some lubricating materials are also to be used. Is it okay?
Yes, sir.
Okay. Am I audible?
Yes, sir.
Hello? Hello?
Yes, sir. Audible, sir.
Okay. So what are the lubricating material? Calcium stearate, zinc stearate, carnauba wax, a special type of wax, carnauba wax. So these are the lubricating materials: calcium stearate, zinc stearate, carnauba wax. Okay. So why this is used? You know, there is a desired property, flowability, plasticity. Now to enhance this property, flowability, plasticity, these lubricating materials are used so that the molding mass can spread to each and every sharp corners, intricate corners of the pattern, right? And also, when I am using lubricating material, it will give ease of removal. You understand? If I want to take out the pattern, then if I have some lubrication, obviously it will be easier. Okay. So all these are placed on the dump box. So we have all observed what is a dump box, or sometime a blowing machine. Where to use blowing machine, where to use dump box. Now, if I use dump box, as we have observed that after placing all the ingredients in the dump box, this is vibrated for some time and then swiveled in this way, and then it is tilted in upside down manner, and then the total mass is deposited on this plate by gravitational attraction, force of gravity. Is not it? So dump box, when I am using dump box, gravitational pull will act. But obviously you can imagine that may not be, the total mass may not be deposited completely on the pattern. So to ensure the perfect deposition or quick deposition, sometimes blowing machines are used. What is blowing machine? Pressurized air will be given so that by virtue of that air pressure, the molding material will be forced to fill up each and every corner. Blowing machine. So blowing machine is suitable for larger number of jobs. Only 1-2 components I am producing. In that case, gravitational force is okay, because some time is needed. Time will be more. But in case of, say, mass number of production, blowing machines are to be used. Quickly, the mass will be deposited. Okay. Now, as again, we have mentioned that the top of the dump box is covered with the preheated metal pattern. So what is the temperature? Approximately 175 degrees centigrade to 350 degrees centigrade. Preheat the metallic pattern from 175 to 350 degrees centigrade. Average is 230 degrees centigrade. Okay. And what is the time? Is 50 to 30 seconds. Okay. Mix the your ingredients thoroughly. Cover the top of the dump box with a preheated metallic pattern. What is the temperature of preheat? 175 degree to 350. Average is 230. Not average. This is approximate. In upside down manner and allow the material to be settled on the metallic pattern. So how long? For 15 to 30 seconds. If it is a box, will add to settle all the materials on the pattern. Otherwise, you may use a blowing machine to force the material to be settled. And a thin shell thus will be formed. What is the thickness? Something about 3.1 to 4.7 millimeter approximately. That is 3 to 5 millimeters, say, on an average. In British system, it is given in inch. That's why the corresponding values in inch also is written here. And again, as I mentioned, that it is then placed in an oven. As soon as the metal is deposited on the metallic pattern, a thin film has been deposited, and then again, this is placed in an oven for half to 1 minute. Half to 1 minute. And what is that temperature? This is the settling temperature. This is the preheating temperature of the metallic pattern. But when the metal has been deposited, molding material has been deposited, then again place the thing in an oven for up to 1 minute. Temperature range is 250 to 300 degrees centigrade. And then remove the pattern. Okay. And how the shell is separated from the pattern, again, that is not manual. One ejector pin is there, ejector pin. So just press one knob, and there are spring operated system. If you press a knob, by virtue of that spring action, the shell will be separated from the metallic pattern. And that metallic pattern can again be utilized to prepare some other shell. But as soon as this half shell is produced, prepare another portion of the shell, and then again align those two cells using guide pins like a cope and drag section. Backing material may also be used in some cases. Backup sand, you know what is backup sand. If needed, backing material may have to be used. And then pour the actual metal inside this. And after final solidification, finally break this shell. So from metal pattern, we are actually preparing a shell using some molding material. Then these shells are used to prepare the final mold. And on that final mold, molten metal is poured. After solidification, the mold which is prepared with the shell is broken. So that is wasted. We can't use that shell again. But the metallic pattern can be utilized time and again. So what are the advantages? Advantages are many more, as we had mentioned, all the same advantage, that is fine tolerance, low cleaning cost, smooth surface finish, sand requirement is also low. This I doubt less skill of the molder is not that true, because obviously a special skill is needed. But this I have doubt with this advantage. Right. But disadvantage means required metallic pattern, which may be costly, and all the fairly expensive equipments, because you must have oven, dump box, other preheating chamber, all these. And also the manpower is not a less skill, but a skill is required. So that should come here only. So this is one of the precision or investment casting. There are many other types, like say here in plaster mold casting, we don't use sand. In precision or investment casting, shell molding particularly, we use ceramic silica sand. But in plaster molding, plaster mold casting is also a precision or investment casting. But here, gypsum based plaster of Paris is used. Gypsum or calcium sulfate. Gypsum or calcium sulfate, which is known as plaster of Paris, a finely powdery substance. And what is the advantage? It dries very quickly. If you prepare a mass, a dough using water, immediately after some time it will be dried. And when it will be dried, that will give very hard structure. So that is the concept, what is utilized here. But what is the problem? It is also not permanent. And as soon as the casting is removed, that is cast part is removed, it must have to be destroyed. You can't reuse the material. Sand you can reuse as a backing material, but here you can't reuse. And here another problem is you must have a very good metallic pattern, especially brass patterns are used. Metallic patterns are used with very close tolerance, right? Now, how it is produced? All these pattern, metallic pattern, are adhered with gypsum-based plaster of Paris. It is covered. Sometimes talc or silica flour is added. Talc as an additive. We had mentioned about additive. So sometime you may add talc or silica flour that will provide strength. Okay. So prepare the mass using say gypsum based say plaster of Paris or calcium sulfate, what is known as calcium sulfate. Mix some talc or silica flour to add strength or to increase strength. Then moisture is not mixed in it, so add some quantity of water and prepare a slurry. Mix thoroughly all the ingredients. So a dough is prepared and a dough is prepared. Dough is
স্যার
prepared.
ওয়াটারটা কি পরিমাণে মানে ওটাতে দিতে হয়?
ওয়াটারের পরিমাণ এটা তোমাকে দেখতে হবে, কেননা it should be judicious. What is the quantity of material and what is the size? And here obviously don't add more water so that the mass becomes fluid. It should be adequate so that you can just apply this paste on the job. So you will have to understand there is no such guideline. This use this much percent or that much percent. Okay, but what is adequate means this depends on experience. If you say pour 1 liter of water in a small quantity, so this will be very fluidic. You can't prepare a say a mold out of it.
Yes.
So a dough is to be produced so that you can prepare a mold which will be retained, which can retain its shape, right? After say application of pressure, etc., it can retain its shape. So that depends on your experience.
আচ্ছা আচ্ছা।
Now this slurry is adhered with the pattern is adhered with this slurry, and it may be vibrated slightly so that this slurry fills each and every sharp corners of the pattern. It is vibrated. If vibration is not always needed, vibration is only needed where there are sharp corners. And for these sharp corners and intricate shapes, etc., undercut, obviously the fluidity must have to be increased. In that case, your quantity of water is to be increased. That's why I'm asking. It depends on
Yes,
the
sir,
type
yes, sir.
of the geometry, type of the job required, all these. But if it is a very, say flat surface, there is no some intricacy, then obviously if you prepare a very fluidic mass, it will not serve your purpose. So it depends. And vibrated to ensure the flow of metal in every nook and corner or cavities, and then allow it to be settled for few minutes. Within 15 minutes, actually, it will be dried. Right? After this, after a few minutes, the plaster will be set. And then take all these together and place in an oven again. Oven. So oven is needed here again, baking oven. And set the temperature at about 815 degrees centigrade. 815 degrees centigrade. Okay, so why it is needed? To remove all the moisture part. Water was mixed in it, but water is not required for the molding mass, so it should be baked. What is the difference with green sand molding? Green sand mold is prepared with green mass, that is sand mixed with water, that is green. And we are pouring molten metal in that green mass. But here, we are not pouring molten metal in the green mass. So, mold is prepared with gypsum-based plaster of Paris using water and other ingredients if required. Then it is baked in an oven. It is dried. So, this is a concept of dry casting. So, dry all this in an oven, placing in an oven to remove all the moisture. Then after pouring the molten metal, you pour the molten metal, allow it to solidify for some time, and then after solidification of the molten metal, again break the mass. And what is the advantage? You may just use surplus water, flash of water, to remove the adhered plaster of Paris on the job. Just wash it thoroughly, it will be clean. But in case of sand casting, after removal of the cast part from the cavity, only washing with clean water will not serve the purpose. So there are various cleaning steps. So later on we shall discuss the cleaning procedure, not ordinary cleaning, sandblasting, use of emery paper, then other say cutting operation may also may have to be followed. So acid cleaning is also to maybe there, but here only ordinary wash with fresh water is sufficient. But there is a problem also. Problem is, we know porosity or permeability is very important property of any molding material, because the dissolved gases will escape through those openings. But here, plaster of Paris is a powdery substance. So opening or permeability, porosity is very, very less. It is a compact mass. That's why the surface smoothness will be very fine. On the contrary, the gases may be entrapped inside the mold cavity. So again, gas-borne defects will be many more. So how to increase the permeability?
হ্যালো,
This plus mold. শোনা গেছে? The problem of plaster of Paris is that it is very fine mass, powdery mass. Okay, শুনতে পেরেছো?
হ্যাঁ
Right, but I must have the property of molding material which is known as porosity or permeability, through which the dissolved gases may escape. Otherwise, if these dissolved gases are entrapped inside the cavity, then many airborne defects may result. What are the defects that will be discussed separately, but timing, you accept this. Gas-borne defects are many more. Plaster of Paris is a powdery mass, fine powder, so it will give compact structure. As a result, smooth surface finish will be obtained, definitely. But entrapped gases may be there. So question is how to increase the permeability of this plaster mold. শোনা গেছে এখন?
Yes, sir.
Yes, sir.
So how to increase the permeability of the plaster mold? There is a process known as Antioch, Antioch, Antioch. So what is Antioch? This is nothing but dehydration followed by rehydration in simple term. Dehydration followed by rehydration. Dehydration means to remove all the moisture artificially, that is in an autoclave. What is an autoclave? Is a pressurized oven. Both pressure and temperature can be set. So dehydrate the part in an autoclave for about 6 to 12 hours. So moisture part will be evaporated. Immediately after that, place the part in an open air, not in any other device. Place the job in an open atmosphere. So atmosphere, again, atmosphere contains moisture. So the job will again be rehydrated. This process is continued for 14 hours. So this is the process Antioch, which will increase the permeability. Right?
Yes,
And
sir.
plaster of Paris mold can generally withstand a maximum temperature of 1200 degrees centigrade. This is important to be noted. 1200 degrees centigrade. But that's why it is suitable for non-metal putty, because when it is melted, it will have 1200. So it can't stand. Hello? শোনা যাচ্ছে না?
এবার যাচ্ছে।
এটা জানি না, নেটের প্রবলেম অনেক সময় হয় এরকম, মাঝে মধ্যেই কেটে যায় মাঝে মধ্যেই। আচ্ছা,
স্যার,
আমি দেখছি একটু পরে,
স্যার,
আমি এখন একটু একটা ব্রেক নেব, 2 মিনিট 3 মিনিট, তারপরে আমি দেখছি যদি আর কিছু এনহান্স করা যায় কিনা।
স্যার ওইটা রিহাইড্রেট করছেন কেন? ডিহাইড্রেট করলে তো মানে ব্যাপারটা ইয়ে হয়ে যাচ্ছে আবার, মানে
না,
rehydrate-
ডিহাইড্রেশন ফলোড বাই রিহাইড্রেশন, এটা হচ্ছে প্রসেস নোন অ্যাজ অ্যান্টিওক প্রসেস, রাইট? ইউ ডিহাইড্রেট দ্য জব in an oven, autoclave. Autoclave is a pressurized oven where both pressure and temperature are controlled, and then immediately rehydrate the job. So this is the process to enhance the permeability. Antioch process. Now this plaster mold can withstand maximum 1200 degrees centigrade. That's why this is not suitable for ferrous metal, but suitable for any other non-ferrous like aluminium, magnesium, zinc, copper-based alloys, that is softer materials. Okay. But you may ask then what to do if I have ferrous metal to be casted in this fashion? So there is a remedy. In that case, instead of using plaster of Paris as a molding material, we use ceramic material, ceramic molding. That technique is known as ceramic molding. Here, ceramic molding. Okay, after some time I shall discuss ceramic molding.
Okay, sir.
So now let us stop for 2-3 minutes. I am checking whether some improvements can be done or not. So after 2-3 minutes, okay. And now, right now it is 11:02, so we may start at 11:56.
Okay, sir.
হ্যাঁ, 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 আচ্ছা। হ্যালো,
Yes, sir.
ইয়েস স্যার।
ওকে, শোনা যাচ্ছে না? ঠিক আছে। নাও, সো so as I have mentioned that this plaster of Paris is having some problem, particularly for ferrous material. That is, temperature it can withstand a maximum of 1200 degrees centigrade. That's why it is suitable for light materials like aluminium, bronze, any other light materials. But for ferrous metal, as the temperature is very high, so ceramic mold casting is the answer. The process is almost similar. Only instead of gypsum-based plaster of Paris, we use some refractory mold material. Refractory mold material like say zircon. In the very first step, we had mentioned about special sand, some special sand like zircon, olivine, chamot, chromium, chrome magnesite, all these. So zircon sand formula is ZrSiO4. Zircon sand is mixed with aluminium oxide, fused silica, just to enhance some properties, and then moisture is added in it. Refractory materials like zircon sand is used, right? So process is almost same. So this is plaster of Paris molding and ceramic molding. But the plaster of Paris molding, ceramic molding, then shell molding, another is there. Lost wax process is also there. So all these are precision or investment casting process, special casting process. Another important casting process, precision or investment, is the carbon dioxide molding. Now, this carbon dioxide molding is basically a hardening process. Hardening process. This one, carbon dioxide molding. This is basically a hardening process. Okay. Particularly suitable for core hardening or also mold hardening. But still then, it is coming under the umbrella of precision or investment casting. This is also known as silicate bonded sand. Silicate bonded sand casting. What is the process? Here, very fine, dry, clay-free silica sand. Mind that clay-free, no clay should be used here as binding material. So dry, clay-free, that is clean sand, any clean, dry sand, conventional sand, maybe conventional means silica sand. The grain fineness number is approximately 75 GFN, right? 75 GFN. So this sand is mixed with approximately 3.5 to 5%. In other source, Kalpakji and Smith, if you go through Kalpakji and Smith, they are referring that 1.5 to 6% of sodium silicate. So let us accept this value, that is 1.5 to 6% sodium silicate. Liquid based binder, this is a very special type of binder, so you must remember this. So dry clay free silica or other conventional sand of approximate grain fineness number 75, right, is mixed with 1.5 to 6% sodium silicate liquid based binder. And this sodium silicate liquid based binder, this sodium silicate is known as water glass. Another name is water glass. That is the trade name, water glass. All these are placed in a dump box or muller and mixed thoroughly. And then the your cope box or drag box is packed properly. Right. 1 minute. I am drawing a figure. The figure is not here, so I am drawing a figure. Is it visible?
Yes, sir.
Okay. So say this is the flask. Okay. And now say this is some pattern. And initially the mouth is open. Okay, so this is the flask, say. And pattern is placed here, and then pack this pattern with this molding material. What is the molding material? Clay free dry silica sand 75 GFN mixed with 1.5 to 6% liquid based sodium silicate or water glass. So packed properly using rammer or etc. And here should be an opening. Open space should be there here. Why? That we will understand later on. So open. Now, as soon as ramming is done, there is a header, also known as carbon dioxide header. Header, or also known as carbon dioxide header. So there are gas pipeline through which carbon dioxide, say cylinder here. Okay, so and all this you can control the flow. So you just tight the or say place this carbon dioxide here like this and pass pressurized carbon dioxide in this chamber. Okay, so when you are supplying pressurized carbon dioxide here, so there must have some opening through which the extra carbon dioxide can pass. Otherwise, it may explode. It is a concealed chamber, so it may explode. So that's why this passage is provided. Okay. So this is the figure, and as soon as, okay, so here when the packing is complete, carbon dioxide is forced into the mold or core at a pressure 20 psi, 20 pound per square inch, pressurized carbon dioxide, and a reaction takes place. What is that reaction? এখানে একটু করতে হবে, এটা Na2O, এই যে দেখাচ্ছি। হ্যাঁ, এটা এখানে ভালো পরিষ্কার হয়নি বলে এটা লিখেছি। এই যে Na2SiO3, this is sodium silicate liquid based binder, water glass, and carbon dioxide is reacting with this water glass. So this will give you Na2CO3 plus SiO2 aqueous. This aqueous SiO2 is known as silica gel. So this is the general equation. Here is the general equation. So Na2O M SiO2, here SiO2 এটা নিচে আসবে, রাইট, এই এটা আসবে। সরি Na2O M SiO2, then H2O. So this is the water glass or silica gel, water glass, liquid based sodium silicate, water glass, and this is reacting with carbon dioxide, CO2. So what is the product? Na2CO3 Na2CO3 plus MSiO2 into XH2O, and this MSiO2 XH2O, this is the sodium silica gel, liquid sodium silicate, that is known as silica gel. Okay, silica, and this silica gel actually is a cement-like substance. So this will act as a binder, and as it is a cement-like substance, so the binding ability is very high. So when the process will be completed, it will give a very hard structure, right? And approximately for smaller jobs, this 15 to 30 seconds is sufficient to hard the say the part. Very quick operation. And another point is, what is the requirement of carbon dioxide, etc. So a thumb rule, not exact, but a thumb rule is to use 0.75 to 0.75 kg of carbon dioxide gas per kg of sodium silicate. Okay, per kg of sodium silicate. So that is a thumb's rule. So this will give you a very hard structure, and as soon as this is produced, you pour molten metal and break the mold, etc. So this is another precision or investment casting, carbon dioxide molding. And last but not the least, another precision casting is very important, lost wax process. Lost wax process. This is also a investment or precision casting. And what is the material? That is pattern material. Here, mind it. No metallic pattern is used in this lost wax. But what is the pattern material? Is some expandable material. Expandable means getting heat, that material will be melted. Say, for example, if I use wax, you know what is wax. So prepare any replica using wax. Are you familiar with have anybody visited some wax museum? So some idols or various legends, etc.
ইয়ে স্যার মাদাম তুসো নাকি একটা নাম আছে স্যার
হ্যাঁ, কোথায়?
মাদাম তুসো নাকি একটা
Madame Tussauds is one. In our country also there are so many. হ্যাঁ, এখানে করেছে একটা, হ্যাঁ, ওটা আমি দেখিনি, কিন্তু তোমার হ্যাঁ, ওটা মেন ওইখানে, এখানেও একটা বোধহয় হয়েছে, ওটা আমি দেখিনি, কিন্তু in your Mysore, Chennai, Mysore, there is a wax museum. Anyway, in different other parts also, in various places. So similarly, if you prepare a wax pattern, very thin section can be produced, wax, and then cover that wax pattern with plaster of Paris mold. Plaster of Paris, say prepare a pattern using wax as a material and adhere the total pattern by plaster of Paris and then dry the mass. So when this is dried, the plaster of Paris, so you must apply heat either in an oven or in open atmosphere or etc. So when you are drying this, there are two advantages. Getting heat, the Paris or plaster of Paris mold will be dried and the structure will become very hard. At the same time, the wax will also be melted from the inside. And as wax is melted, it is coming down, keeping behind a cavity. Are you getting my point? When you are heating the mold, plaster of Paris is dried and is becoming harder. At the same time, wax is also melted and a cavity is prepared inside. Now, in this void space, pour molten metal, say aluminum or anything. Then allow it to solve.
এই ব্যাপারটা একবার স্যার একটু বলুন স্যার কি হচ্ছে মানে বুঝতে পারলাম না
এটা say this is a wax pattern. Wax. So cover this wax pattern with plaster of Paris material. Plaster of Paris. So inside there is wax.
Yes.
And now apply heat. Now this is a traditional process also. Some of you might have heard the name of Dokra casting in some parts of our country, or in, say, in Madhya Pradesh or in our Chatna area, Bankura district, Purulia. So there are the traditional craftsmen, and this art is known as Dokra Shilpo. It is almost abolished nowadays. But what they used to do, they prepare a pattern, any pattern, using wax, cover it with some plaster or something, then apply heat overnight. So when it is heated, plaster of Paris mold, leaving moisture in the atmosphere, it is dried, it is baked. So the structure
Yes.
becomes very hard. At the same time, getting this heat, this wax is also melted. Wax will also melt. And there
Right.
are some provision so that this molten metal can come out. So as soon as wax is melted, so a cavity will be formed here. A cavity is formed. So this is very hard structure. Inside there is a cavity. Now, again, this is not as simple. You will have to provide some gate, riser, runner, all these to pour molten metal. So after that, you pour molten metal, and now the molten metal, say aluminum or the exact material, what is needed, maybe radioactive metal also. So fill this cavity with that material and allow it to solidify. After solidification, break this mold, plaster of Paris mold. And what is the advantage? After breaking, you just wash using clean, fresh water. And then your job will be prepared. So this is the process of lost wax process. Dokra casting is something like this. If you visit in, I don't know how to visit or whether you will be allowed or not. It's permission, you must take permission, but in our Rabindra Bharati University on BT Road, they have this department that is what is called Fine Arts Department. So in that department, there are so many sculptures, and they are also have laboratories. Okay, oven, all these are there. So they also prepare these type of things, right? But that is from the art point of view. But same thing when it is applied in engineering, and particularly this is important nowadays with the advent of additive manufacturing process, because additive manufacturing we shall discuss, or 3D printing, by utilizing this process, very thin section, very intricate shape, geometries can be produced, and that material is your plastic materials, right? Thermoplastic.
Yes.
So that object is produced, plastic material, and that may be used as a replica in case of lost wax process. Though traditionally we use wax, but nowadays instead of wax, these polyester materials like uh, 1 minute. So nowadays this material is thermoplastic polystyrene resin. So insofar as the 3D printing, additive manufacturing, this is concerned, instead of using wax, we may use thermoplastic polystyrene resin, and there are many applications, engineering applications. 3D printing amalgamated with casting. 3D printing itself is a process similar like a casting, but when pattern is prepared utilizing sophisticated material like thermoplastic polystyrene resin, and in lost wax process, what is the disadvantage? If you want to produce a pattern using lost wax, you must have very special skill, artistic skill. Otherwise, you can't produce. Right? It is not that easy. That's why I have mentioned, if you visit this fine art section of Rabindra Bharati University, so that is a artistic arena. Okay, but if you use 3D printer, CNC controlled machines, so you may design, you may program. You are familiar with AutoCAD or other drawing. So make a program, that is, make a drawing, and then that drawing will be transferred into printable form, and CNC controlled machines will take care of all these. So very thin section, intricate parts, complex geometrical shapes can be produced. So using thermoplastic polystyrene resin. Okay, so this is lost wax process. Nowadays, we may use thermoplastic polystyrene resin instead of wax. We have discussed ceramic molding. So these are special casting processes. Along with, we have some other special casting processes. Like okay, some other special casting processes. Up till now, what we had discussed is meant for some fewer parts. Okay. Now regarding this, okay, that will come. Okay. So up till now, what we had discussed is basically applicable for fewer parts, but for say mass production, is it rather feasible to prepare the mold time and again using green sand, break the thing and again
No,
reproduce?
sir.
It will be difficult.
Yes.
So for mass production in industries, automated foundries, they use some other techniques. Very important is gravity die or permanent mold casting, where there is a permanent mold here. In ordinary green sand mold, you are preparing a single mold, making a job, breaking the mold. Time and again, you are breaking the mold. But here we have a permanent. Mainly the gray cast iron, or some alloy steels or some other material which is permanent in nature, that is used as a die. And beauty of this technique is, say this is one half of the mold, another half, another half. So here I must have some gate riser runner. So what is again gate riser runner? Things will be discussed in detail, but from your experience about say workshop, in our workshop also we had observed the video where sprue pins were used to provide one runner through which molten metal will be poured, and one riser. Riser is meant for reservoir, extra material. Why extra material is needed? Because during solidification, metal will shrink, And to compensate that sinkage, extra material is needed. So here, I don't require to provide gate, riser time and again, because already in the mold, permanent mold, it is prepared. Metallic mold. So all these are prepared. Only when they are united, these two parts are united here. So things are ready. You can pour molten metal. And this is the riser. That is the reservoir. Okay. So now you clip these two parts, pour molten metal. After solidification, separate these two halves, take out the part.
Yes, sir.
So this is for mass production and also mainly for non-ferrous material. Non-ferrous material. And as non-ferrous materials are molded, that's why cast iron is or steel are suitable as a die material. But if it is ferrous material, obviously cast iron or steel will not be suitable because same material. Okay. So this is a gravity die. And why it is gravity die? Because observe here, the metal is poured from the top and it is flowing by virtue of gravitational force of attraction. Okay. It is placed in a vertical manner. So metal is flowing, it is coming down by gravitational force of attraction. That's why it is known as gravity die casting. This is another shape, same thing, but you try to understand that difference between these two. Here, this is a completely separate part, completely separate part. There are ejector pins, guide pins. They are united and clipped here. But in this figure, these two parts are hinged here like a book. Book, you can open the book in this fashion or close the book. Same. So here it is rigidly fixed here. Okay. So
Yes, sir.
mesh the two part, clip this, there is a clip, and then pour molten metal. All these are riser, pouring gate, basin. After solidification, you again open, take out the part, again close, again pour molten metal, and so on. In some of you might have noticed. Can you give me some example? In this is a very in roadsides. Some ring, bronze ring or something is produced using two die halves. They are pouring molten metal, and immediately after some time it is solidified. Then using some files, etc., or some liquid for cleaning, the rings are produced. Have you observed that technique?
Yes, sir.
So try to identify those things when you are moving in and around. So all these are available. Similarly, another mass production technique, die casting and pressurized die casting. This is known as gravity die casting. Gravity die or permanent mold. Why it is gravity? Because molten metal is flowing by virtue of gravitational force of attraction. But same thing when again die is used, permanent die is used, but not by virtue of gravitational force, but we are forcing the material into the die. So that is pressurized die casting. And what may be the pressure? The range is 100 to 1 lakh pound per square inch. 1 lakh is meant for very high job, large job, 100 for smaller job. That is, instead of gravitational force of attraction, pressure is used, hydraulic pressure or pneumatic pressure. Pressure range may be 100 to 1 lakh psi. So, say if you pump, say in a piston, you are pulling the fluid and then pumping. So, fluid will come out. Okay, so that is the concept. Again, depending on the type of operation, there are two types. One is called gooseneck, goose, হাঁস যাকে বলে হাঁস, হাঁসের মতো, হাঁসের ঠোঁট, gooseneck, sorry, হাঁসের ঠোঁট নয়, হাঁসের ঘাড় যেটা. One is just due to this pot looks like a gooseneck. This is the pot. Okay. One is called gooseneck or air injection type, right? And other is submerged plunger type. Now here, this is the gooseneck or air injection. What is happening? This is the furnace, fire lining, refractory lining. This is the fire place, burner. So fuel is coming, ignited here, fire is initiated, and here is a crucible, porcelain crucible maybe. So metal is melted here, molten metal is there. Getting heat, metal is melted continuously. So this is a molten metal bath. And there is a arrangement, mechanical arrangement, and this is connected with the gooseneck pot. So you just observe this arrow. Sometime this is dipped, gooseneck is dipped inside this pot, and it will be filled with the molten metal. As soon as it is filled with molten metal, then by virtue of this mechanism, advance this gooseneck filled with molten metal to the die section. So this is permanently fixed here. So one is movable, one is permanently fixed, stationary. So align these two die previously and filling this pot with molten metal, bring the mouth somewhere here, and now apply pressure, or by virtue of air pressure, atmospheric pressure, the metal will be forced to enter in this cavity. Right? So this is the mold cavity.
Yes, sir.
And after solidification, remove this movable die, take out the object. Again, insert the movable die, dip the emptied pot here, again lift, advance, inject, fill the cavities, allow to solidify, remove the cast. So this is the gooseneck or air injection type of system. Here, what is the thing? Gooseneck pot is just moving in up and down manner. Also, it is advancing here and it is coming back, advancing, coming back, dipping below, moving up, advancing. So this is mobile. On the contrary, we may have another arrangement. Here, you just observe, this is also a gooseneck. It is permanently fitted with this input. Here, this is the mold cavity. And here is a plunger, piston cylinder type of arrangement. So when this plunger moves up, it will attract molten metal. So this is a metal bath where the gooseneck is permanently immersed. So when this plunger is piston, to me, piston, pitchkari, অনেকেই জানো, when you are pulling the handle, so fluid will enter and now apply pressure. So that will be forced to come out through this opening or mouth of the gooseneck and the cavities will be fulfilled. Again, you immerse this plunger, pull it up, apply pressure, metal will be forced to enter.
প্রেসারটা আর কি ওই পিস্টনের ওই অ্যারেঞ্জমেন্টটা দিয়ে হচ্ছে?
পিস্টনে কি হয়, আমি যখন পাম্পার যখন টানছি ফ্লুইড উঠে আসছে,
ইয়েস।
আবার যখন অ্যাপ্লাই করছি প্রেসার তখন ইট ইজ ফোর্স টু. So here system is not that simple because when I am pulling, right, and when I am applying pressure, so there are some control valves also one way, pulling and applying pressure. So there are control valves so that during the application of pressure, when the plunger will come down, when the plunger moves down, it will apply pressure so that the metal is forced to come out through this mouth. So systems are accordingly there. And there may be another valve in somewhere here. So when I am pulling it up, that valve will be opened. But when I am applying pressure, like say something, this is not as simple, but I am just for the understanding. Say there is a valve. So when the plunger is moving up, right, moving up, so this is the liquid pot. So liquid is forced to, so the valve is opened by this liquid pressure. But when plunger is moving down, applying pressure in this way, so valve will be pushed back.
Yes, sir, yes.
So this lid will be closed. But at the same time, say if this is the mouth of the gooseneck, another valve will be there. Getting this pressure, this valve will be opened.
আচ্ছা।
Something like that, not as simple. That is the one-way valve. Something like that. So what is the difference here? The pot is permanently dipped inside the pot, the molten bath, and only the plunger is moving up and down. So that is very rapid action. For mass production, this is suitable. Another mechanized system for mass production, automated system, is centrifugal casting, particularly for hollow casting, like say barrel, cast iron pipe, hollow pipe, then gun barrel, lamppost. All of you are familiar with this type of parts: cylindrical, hollow cylindrical, symmetrical. So here this is the chamber and molten metal is poured here, and the total chamber is provided a rotary motion by virtue of these motors. All these arrangements are there. So motor, so all the your die will rotate. So centrifugal force of attraction will actually act. Centrifugal force of attraction. Like say when this
হ্যালো, শোনা যাচ্ছে না।
ইয়েস
Equal. The deposition of molten material will be
স্যার আবার একটু
equal.
প্রথম থেকে একটু বলুন
এই জায়গাটা,
হ্যাঁ পুরোটাই স্যার একবার একটুখানি
this is a cylindrical casting, centrifugal casting, and when the cylinder is rotated by motor, okay, so this will have a rotary motion, and molten metal is poured here, and molten metal will be by centrifugal force of attraction, this will be forced to be deposited in the outer periphery here. Okay, so deposition will be equal, thickness everywhere will be equal, and molten metal being heavier than the impurities, so molten metal will be deposited first, and finally here the impurities will be deposited last. So later on I can remove the impurities very easily because molten metal is heavier, so that will be forced first here, so that will make the outermost shell, and now open the two halves, separate it, the hollow pipe will be ready. Okay, so this is centrifugal casting.
ইয়েস
But again, out of centrifugal casting there are three types. So this is the arrangement. So there are three types of centrifugal casting. What are those three types? One is called true centrifugal casting. True centrifugal casting means hollow pipes, gun barrels, lamp posts. হ্যালো, বলো।
ক্যাটাগরি
What
ওইগুলো
are
ওই ট্রু
category? একটা ট্রু সেন্ট্রিফিউগাল কাস্টিং, ওকে, শোনা গেছে? ট্রু সেন্ট্রিফিউগাল কাস্টিং।
Yes, sir.
ইয়েস স্যার
Second one is semi-centrifugal casting. True centrifugal casting means like hollow cylinder pipe, throughout its length the thickness is same. Semi-centrifugal casting means parts with rotary symmetry, like say this is here, this is a wheel with spokes, not a hollow cylinder, but there are some spokes, say wheel of the cart, wheel of rickshaw, etc.
Yes, sir.
So that is a semi-centrifugal, not exactly a through hole, but some spokes, etc. are there. So die is designed accordingly. And another one is centrifuging or centrifuge casting. Centrifuging or centrifuge casting is used for mass production, but not necessarily for producing hollow section. That is important to note. We may have any other shape, maybe solid square block, solid block, etc. But similar type of shapes like here, say in a rotary table, this is rotating, that's why the term centrifuge or centrifuging. So molten metal is poured here, through the openings it is forced to enter in various die cavities, where you just observe here, that is not a cylindrical part, that is something different. So 1, 2, 3, 4. We may provide so many other. Say we may arrange, say this is the rotary table. We may provide so many sections at a time, not hollow, cylindrical, etc., but some other geometrical shapes. Okay, so place so many objects in the table and provide molten metal here, and as soon as this will be rotated, metal will be forced. So we must have gate all this. Okay, so all the cavities will receive metal equally. So this is the concept of centrifuging or centrifuge casting, right? Centrifuging or centrifuge casting. This is a vertical screw where molten metal is poured, and this table is connected with a motor and it is rotated. So this vertical screw is also rotating. By virtue of centrifugal force of attraction, molten metal is forced to enter through various your runner. These are the runners, and finally to the cavities. So at a time, number of equal parts are produced. So this is for mass production, and this is automated. Any question up to this?
No, sir.
Okay. So last quickly, we shall discuss. Okay, the casting defects is rather, so quickly we may discuss. Time and again we have mentioned the runner riser. In the demonstration also, we had introduced one is meant for runner, that is pouring molten metal. Another is for riser. But runner is not as simple as that. So what are there? So this is the concept of gate through which molten metal will enter. So there are various components, like this is a cup-shaped part, cup. Okay, so this top portion where molten metal will be poured here directly, not directly on this duct, but on the cup. So this is known as pouring basin. What is the advantage? If molten metal is dissolved with larger impurities, some foreign materials like say wooden strip, leaf, cotton, jute, all these impurities, then those will be arrested. Immediately those will be arrested. Okay. So comparatively pure metal will enter in the cavity. So after pouring molten metal in this pouring basin, next is, this is the down gate, the vertical down gate. Again, somewhere here, there is a strainer. This is ceramic material. Strainer is used to remove dross. Dross, what is dross? Is nothing but oxides. Sulfur oxide, nitrogen oxide, various other oxides. So to remove oxide scales, ceramic strainers are used. Chakni. Okay. This is the down gate. So after pouring in the pouring basin, it is crossing strainer, ceramic strainer, to remove your dross, means oxides, various oxides, NOx, SOx. Then metal is flowing through the down gate. This is the down gate. Is not written here, but down gate. And this is known as sprue base well. Sprue base well. And there is a splash core. Splash core to minimize eroding effect. What is erosion? Well, say a river is flowing in a river, right? It will wash out the sand particles from the banks. You are familiar with the what is called is landslides, okay? When river is flowing, it will just wash out the loose sand from the banks. মাঝে মধ্যেই হচ্ছে, দেখায় ছবিতে ভেঙে পড়ছে, পাহাড় ভেঙে পড়ছে. So that is erosion. Similarly, when molten metal will be poured from elevated height, it may wash out sand particles from the face if ramming is not proper, or if the molding sand is not having adequate additive properties. That's why sometimes we may use some additive, some binders to enhance those properties. But again, to start with, a splash core is provided in the sprue base well so that the eroding effect is minimized. So when molten metal is entered here, this portion is actually the runner, this horizontal. Mind that. This is the runner, but for the simplicity of the purpose, in the drawing or during the discussion, we call it this as a runner through which molten metal is entering. But that is not wrong. That is not true. This is the down gate. This is the pouring basin. This part is the runner. Horizontal. Very important point. And finally, through which the molten metal is finally entering into the cavity. This is the mold cavity. This is known as ingate. Ingate. There may be many more ingates, not a single. Later on we shall discuss. And on the runner, so there are strainer, splash core, and another trap. Trap. It is known as skim bob. SKIM BOB. Skim bob is a circular device. Upper half is located in the upper portion. Lower half is located in the lower portion. This is a trap to separate lighter impurities as well as heavier impurities. Heavier impurities will be settled in the lower half, whereas lighter impurities will float over the molten metal and it will be trapped in this upper compartment. So later on, after solidification, we may remove all these impurities. So this is a skim bob. So this is all about the gating system.
Okay, sir.
Yes, sir.
Any question up to here?
No, sir.
No, sir.
No,
Okay, then if you don't have any question, we may conclude. But before that, how can I send you this figure? Because these are the casting defects. Okay. Because you get it be copied, because when in the next class we shall discuss the casting defects, that time I shall not draw this figure on the board. But if you have this figure, we can discuss what are these, all these 1,
Yes,
2, 3, etc., etc. Right? So
হ্যাঁ স্যার,
that
স্যার
is
যে পিডিএফ গুলো ছিল স্যার, ওটা আর পিপিটিটা যেটা ছিল স্যার, আপনি পড়াচ্ছিলেন লাস্ট উইক।
আজকে
না না স্যার, পিপিটি আপনি আগে একটা পড়েছিলেন, একটা 60 স্লাইডস মোটামুটি ছিল এই স্যান্ড কাস্টিং এর উপর।
সবগুলো তোমাদের তো পড়ানো হয়নি এখন, যেটুকু পড়ানো হয়েছে তার রেলিভেন্ট পোর্শন যেটা পাবে না বইতে সেইটুকু আমি দিয়ে দিতে পারি। বা it is not a note. Don't take this as a note because all these are only salient points. So you must
Yes,
read
yes,
books
sir. Just
also.
for reference, sir.
For reference, I may give. But I shall send you some pictures like this or something, which I shall talk in the next class. So if I want to draw figures, all this will time consuming. So you just by that time you either you preserve it in your mobile or elsewhere. So open those figures when these will be discussed. So without drawing, we can discuss those things. So now, Siyar,